Hello everyone, my name is Teacher Carl. How are you today? Okay, I'm good. Please get your book, Science and Action 4. Okay. And please open your book on page 102. Okay, page 102. Okay, so let me explain you about incident ray and refraction ray. Okay, so when light moves from a medium which is less dense to a medium that is more dense, example, light moves from air to water, the light will refract towards the normal line. Okay, so here, look at the picture here. So there, when light moves from a medium which is less dense to a medium that is more dense, light, example, light and water. Okay, so air to water, air to water. Okay, so that's our medium, air to water, and the line the line between the refraction ray and incident ray is called the normal line. Okay, so this line in the middle is called the normal line, and this one here is called the incident ray, and the line here is called the refraction ray. Okay, so this one is the incident angle, and this one is the refraction angle. Okay, so there, the light will refract towards the normal line. Okay, and then here, okay, so here, when light moves from a medium which is more dense to a medium which is less dense, example, light moves from water to air. Okay, so this is from water to air, the light will refract away from the normal line. Okay, so example here, so here let's change the, okay, so here light refracts away from the normal line. Okay, so here, when light moves from a medium which is more dense to a medium which is less dense. Okay? Example is light moves from water to air. The light will refract away from the normal line. Okay, so there. So the light refracts away from the normal line. Okay, so there you are. So this is the normal line, and this is the refraction angle. And then this is the incident angle, the refraction ray. Okay, so it's opposite. Okay, opposite with the light moves, when light moves to a less dense. Okay, so they are opposite, right? Okay, now please open your book on page 103. So page 103, we can see objects because light from the object reflects into our eyes. The light from objects reflecting into our eyes declines when it moves from water to air. Okay, so here, observer's eyes, for example, look at the picture here. So observer's eyes, and then water surface, and then picture object. This is the movement of light. So this figure shows the movement of light from an object to an observer's eyes. Okay, so many objects such as eyeglasses, magnifying glasses, camera, telescopes, and binoculars imitate the refraction of light. The critical angle is the incidence angle that creates a 90-degree reflection angle. Sorry. Okay, so there. Sorry, okay. So again, the critical angle is the incidence angle that creates a 90-degree reflection angle. It occurs when light moves from a medium that is more dense to a medium that is less dense. Okay, so there. Look at the picture. So this one is the refraction angle here. Okay, and this one is the incidence angle, the critical angle. Okay, they're less dense, and this is the dense. Okay, here. And the next is the complete reflection is the phenomenon where the light ray returns back to the medium. So it creates an incident incidence angle, which is bigger than the critical angle. Okay, so the complete reflection is the phenomenon where the light ray returns back to the medium. So it creates an incidence angle which is bigger than the critical angle. Okay, here, observing underwater objects. Okay, so let's observe underwater objects. Materials, rulers, two glasses, two pencils, and water. Okay, and then method, fill one glass 3/4 full and leave the other one empty. Put one pencil into glass and then observe the pencils. Number 3, repeat step 2, but this time use rulers and then observe the rulers. Okay, so I will send you a supporting video about this experiment, okay? And then here, okay, so when light, look at the picture, okay, so this is the pencil, water, and pencil in water. When light moves through different media, the light will change speed. This makes objects appear differently when we put them in water. This phenomenon is called a refracted ray. This is called a refracted ray. Okay, so that's it. Okay, so please watch the video for the supporting video for this experiment, okay? For you to understand it more. Okay, and then another topic is white light and rainbows. Okay, so white light and rainbows. White light. White light is light from the sun or light bulbs that when we see it, it appears white in color. However, when we look at white light by using suitable equipment such as a prism, we can split the white light into 7 colors, which are purple, indigo, blue, green, yellow, orange, and red. Okay, so that's the rainbow color, right? The wavelengths of these colors are different. So the light refracts differently, which creates these 7 different colors. Okay? The wavelengths of each colors are different, so the light refracts differently, which creates these 7 colors. Okay, so next meeting we will have an experiment with this. Okay, we will answer the page 105. Okay, for the meantime, that's all for today. Okay, so please watch the supporting video more about refracted ray. Okay? Okay, so that's it for today. Goodbye, everyone. Thank you.